Hi all, this is Miss Billerbeck and I am teaching you from my kitchen table. I hope you're all well. This is 11.1, solving simple inequalities. So if we remember this inequality sign, I kind of made a fancy one for you so you could see it with the green and all. So this side is the big side and this side's the little side. So that's one way to realize the big fits into the opening and the little side, it's pointing to the little side. Okay, so let's look at Stefan has more paper than me. Lucky Stefan. So we're going to call Stefan S and me M. So if Stefan has more means this than me. So Stefan has more paper than me. That's what we would say with our lovely math shorthand. Now let's look at this. They only have $20 to spend. So the infinite they is going to be T. So T, and they only have $20. So let's put $20 here and decide what to do. Now, can they spend $20? Absolutely. So we can put an equal sign there. Can they spend $19? Can they spend $18? Can they spend $10? Yes, they can spend anything less than $20. But they can't spend $21. They don't have it. You know, they go into debt, what we always talk about when we're doing the negative numbers. So that is how we would use inequalities in our real life, to use, quick shorthand to say something like they only have $20 to spend. So let's look at some more examples of real life things. We cannot have the dance if we do not have 50 or more scholars attend. So if we say S is scholars, so we have scholars and we have 50. So we have to decide, can we have the dance if we have 50 scholars? Yes. So we're going to have an equal sign. Can we have the dance if we have 49 scholars? It says 50 or more. Is 49 50 or more? No. So 49 is less than 50, so we can't have a 49 here. Okay, can we have 100 here? 50 or more. 100, does it work? I think it does. So it looks like we can have a greater sign here because 100 works. So 100 is greater than or equal to 50. Yeah, that works. So we did a little shorthand for saying we cannot have the dance if we do not have 50 or more scholars attend. Now here's another one. My neighbor has fewer eggs than me. So fewer eggs than me. So if we say my neighbor is N, and again, I'm going to be M for me. I have 10 eggs, by the way. I think I do. I'm rationing them. Trying not to leave the house. Okay, so we're going 10 for my eggs. And my neighbor is here. So then we look at my neighbor has fewer eggs than me. So could my neighbor have 8 eggs? Is that fewer than my 10 eggs? Yes. So could my neighbor have 20 eggs? Is that fewer than my 10 eggs? No. So we're going to put N is less than. So this says my neighbor has less eggs than me. So if M equals 10, that's why I could write 10 there. So I had N is less than my neighbor has less eggs than me. So that's my little shorthand. Okay, and that's why we create all these math symbols. They're not just to torture you. I know. Sometimes that's what you think. Okay, so let's look at this. What it says? X is less than 21. So I guess I wrote this badly. So what does this say? Let's just erase that. Okay, so let's write what it says. So X is less than 21. So X, and then we have 21, and we're going to put the little point toward X because it's less than 21. X is less than or equal to. So this one was just less than. This one's less than or equal to. So this one we're going to write X is less than, and we're going to put a bar right there with 21. X is greater than, so this one we're going to write X, and X is going to be bigger than 40, so it opens up toward the X this time, and 40, because it's greater than 40. And this one we have greater than or equal to. So we have X is greater than or equal to 40. So there you have it. How to convert what's being said to the actual symbols. All right, let's look at this. All right, so we're going to look at what sign should we use. So we either the greater than, less than, or equal. Okay, so we have 7 and negative 11. Is 7 greater than negative 11? It is. So we're going to write this sign. Is negative 3 greater than 10? Negative 10? Which one's closer to 0? That's what makes it greater. So negative $3 in debt is much better than negative $10 in debt, don't you think? So this means you have a little less debt. So it is greater than negative 10. What about 5 and 18? You got it. We're going to put a less than sign here because 5 is definitely less than 18. We have 0 and negative 21. Believe it or not, 0 is greater than negative 21. And what about 47 and 47? Well, we know that one. That's silly. You're probably going, Ms. Billerback. All right. So let's double check. Is everything right? Yes. Okay. So now if we use these variables, which make things a little scarier, let's take a look at what it means. So if A is less than B, that's like, is 3 less than 4? And K is greater than 0. That means we're dealing with a positive number when it says K is greater than 0. Then if, let's say, K is 2 is greater than 0. So that's the same thing as saying it 2 times 3 and 2 times 4. Okay, so that puts these weird variables into a little bit of perspective, right? So we know that 2 times 3 is 6 and 2 times 4 is 8. So is 2 times 3 6? Less than or greater than 2 times 4, 8? It's definitely less than. So we're going to make this rule less than. Okay, so whenever you get scared with the variables, just find some numbers that are tangible to you, that make sense to you, that you can grasp, and put those numbers in for the variables and so that you have something more real to work with. So here we have A and is greater than B, and K is greater than 0. So that just means it's positive. Okay, we're not dealing with any negative numbers here. So then KA and KB, what sign do we use? So if we use the same format here, we had 2 times 3. Whoops, this time A is greater. So we're going to have to do 5, and let's make this one 2. Okay, so 2 times 5, and then we have, and K is 2, by the way, 2 times 2. So we have 10 and we have 4. So 10 is definitely greater than 4. So then this would be greater than, KA would be greater than KB. Okay? So there's workarounds when you're dealing with variables and you're like, oh no, Miss B, that's a little too much for me. Well, just use some workarounds so it's not so scary, okay? All right, let's do an example. All right, so is 12 the solution to 3x is less than 36? Well, yikes, what do? We have an inequality and we have to solve for x. Okay, well, let's make it a little less scary and do something that we know what we know how to do. So let's go and make it 3x equals 36. We've got this, right? 3 times x, what's the opposite of multiplication? That's right, division. So we're going to divide 3x by 3, and we get x equals 12. And now we just are dealing with an x and a number. So now we go back and we say, oh, we started with this. So let's put that back in. So x is less than 12. This says, is 12 a solution to this? So is this true? Is 12 less than 12? What do you think? That's a big old, let me get a special pen for this one. No. So it is not a solution. 12 equals 12. Okay, 12 is not less than 12. So it is not a solution. Okay, so let's look at the next one. All right, so we've got something that looks a little scary, eh? Well, let's rewrite this with that equal sign so it's a little more manageable. Okay, remember, we gotta make sure the fear doesn't get us. So let's change it to something that doesn't make us so afraid. Okay, but I realize that I put a fraction in here, and that's really scary, but you know how to be a ninja at getting rid of fractions, right? What do we use to get rid of this fraction? It starts with an R, and we're going to multiply both sides by that. What is this? Okay, it starts with reciprocal. Okay, so we're going to use a reciprocal. There we go. So now we're going to write 7 over 2, which is the reciprocal. And if we do it to this side, we do it to this side. Okay, and what that does is that cancels, and that cancels. And we just have x equals, and if this is over 1, we can take the 2 out here, or, let's not. Okay, we're dealing with some scary fractions. Let's not reduce this just yet. We are going to reduce it, though. Okay, so 7 times 6 is, and there's a negative there, 42 over 2. They both are divisible by 2. Hello. Hi, little bug. Okay, they both are divisible by 2, and we have 42 divided by 2. So that's 21 over 1, and 21 over 1 is just 21. So we remember what we started with, that sign, and we write x is greater than 21. So now we look at, is 0 a solution to this? So we try, is 0 greater than 21? And we think about it, and we're like, oh, we know that answer. No. Okay, so 0 is not a solution to this equation here. Oh, wait a second. Ho, 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 what did I forget? Oh dear, no one caught me because you're at home. Okay, so I forgot a negative. Oh my goodness, look at that. How important are these negatives, I tell you. So don't forget your negative. So now we put it in, is 0 greater than negative 21? Can you see how those little negatives are going to mess you up? So, yes, 0 is a solution. 0 is greater than negative 21. So don't forget your negative signs, please. All right. Let's go to example 3. All right, so we have, is negative 5 a solution to negative 2 x is less than 8? All right, so let's do the old changing of the sign, make it something we can handle. And now we're going to divide by that negative 2, because we have negative 2 multiplying by x. The way to undo it is to do the opposite operation, which is division. So now we have x equals negative 4. Now, I taught you in the last 2 examples that you just bring that inequality sign down here. However, warning, warning, warning. We divided by a negative. Okay, so when you divide or multiply by a negative, flip the sign. Okay, so that's pretty darned important. So let's remember not to forget to flip the sign. So we flip it like this. X is greater than or equal to negative 4. Okay, so the way we check that is, okay, we have negative 5. Is negative 5 greater than negative 4? Whoops. Well, of course, it's greater than or equal to negative 5. But is it greater than or equal to negative 4? No. But if we had flipped the sign, we wouldn't have gotten that right. It would have said negative 5 is less than or equal to negative 4, and that would have been true. But let's put the negative 5 in here and see if it's true up here. So if we put negative 2 times negative 5 in up here, and then is less than or equal to 8, that gives us positive 10, because we have negative times a negative is a positive, and that is less than or equal to 8. And that is not true. Okay, so it was not a solution here when we actually plugged the number in. And when we did the math, if we forgot to flip the sign, we would have been in big trouble, huh? So when you're dividing or multiplying by a negative, flip the sign. It's very important. All right, so let's look at the next one. All right, so we have, is 0 solution to negative 4/9 x? You're probably saying, Miss Billerbeck, you put another fraction in there? Really? Yes. Yes, I did. Because if you learn how to do fractions now, you won't be afraid of them later. So you might as well just face that fraction fear and get rid of it. Okay, so we have negative 4/9. Okay, so what do we actually do to get rid of this fraction again? It started with an R. So starts with a re. Yes, reciprocal. Okay, so we're going to use reciprocal. So we have a negative here, so we have to put a negative here, and then 9/4. So we're multiplying by a reciprocal, negative 9/4. So that cancels this, cancels that, cancels that, cancels that. So we get x equals, and then this is going to be negative times a negative is 72/4. We can divide both by 4. And we end up getting 18/1, which is 18. Okay, we're going to substitute this sign back in here, but before we do that, we see we multiplied by a negative. What do? We multiplied by a negative. What do we do? What happens to this sign? This sign here. That's right, it flips. We flip the sign. So instead of the point being on this side, the point's going to be over here to make it not a greater than or equal sign, but a less than or equal sign. So now we have 0 is less than or equal to 18. Is that true? Yes, it is true. And 0 is a solution to this. Now, if we checked it really quickly, 0 times anything is 0. Is 0 greater than -8? Yes. Okay, so I hope this lesson finds you well. I think you're ready to do your exercises now. So I'll attach this to that exercise sheet. Have a wonderful day and be safe.